Okay, chapter 2 is called Reasoning and Proof. 2.1 is Conditional Statements. This chapter is going to feel a little strange. It's not really going to feel like math because it's not even particularly going to feel like geometry, what you might think geometry is. It's more like logic. So there's going to be some sentence writing, um, which seems a little strange in a class like this, but that's going to lead us into some mathematical thinking and some logic that we're going to use to do proofs. Okay, so first off, a conditional statement. A conditional statement is just an if-then statement. So if whatever, comma, then whatever. It's an if-then statement. Okay, it needs those two words. It also needs the comma in the middle to separate the two parts of it. So don't leave the comma out. That's part of it. Okay, and there's a symbolic form that you'll see sometimes, which is a lowercase p, and then it has an arrow pointing to a lowercase q. Okay, that's just supposed to represent the if part leads to the then part. Okay, all right. So this example here says, if you live in Walnut Creek, then you live in California. So the part that follows the if and ends right before the comma is called the hypothesis. Okay, and the symbol we use for that is a lowercase p. The part that follows the then is the conclusion, and that is symbolized by Q. So that's why we've got P to Q. A hypothesis leads to a conclusion, in other words. Okay, so this is just a symbolic way of writing that out. Okay. Okay, and so this next example says, rewrite this as a conditional. So I'm just going to take this sentence, this very simple sentence, and write it as an if-then. Okay, so there's different ways you can do that. There's not one particular way, but I just have to take that information and transform it into an if-then with a comma in there. So you can't just say if birds then can fly, or if birds can, comma, then fly. That doesn't make sense, right? So I want to construct a sentence that's in that format that makes sense. So I'm going to say if an animal is a bird, then it can fly. And there are certainly other sentences you could have come up with that would work. You could have said, if something is a bird, then it can fly, something like that. Okay? All right, so just to separate this here from the next part. Okay, so then we're on to a negation. So a negation is something that has the opposite truth value. Okay, so let's look at this next example. We're going to write the negation of these different statements. So the negation of the sky is blue. Some people might say the sky is yellow or the sky is red or something like that. But that's not the negation. I want to cover everything except the sky being blue. So a lot of times you can just put the word not in there or change the is to isn't, and that will work here. So I'm going to say the sky is not blue. That has that's it's kind of like the opposite. Okay, so when I said truth value, let's say the sky is blue right now when I look outside. So that would be a true statement if the sky really is blue. And then, so if I made this statement at the same time, it has the opposite truth value, just meaning that if one of them is true, then the other one is false. So if this were true, then that would have to be false. Okay? All right, that's what I meant by the truth value when I was talking about the negation. Okay? All right, part B, Jim is not tall. So if the word not or isn't is in the statement, you can just take it out. So I can say Jim is tall. So often it's as simple as just putting the word not in or removing it if it's in there, okay? So here again, though, some people will fall for the it's rainy, but there's other things it can be besides sunny and rainy, right? It could be cloudy and not raining or something like that, okay? So I want to cover all of the things that aren't sunny, so I'm going to say it is not sunny, or you could use the contraction isn't, that's fine too, okay? And so on my last one, I don't want to say something like x equals 4 and x equals 5 because I want to cover all of the things that could be. So it can be anything but 3. So I could write out x isn't 3, but to do that mathematically, I'm going to do that. That just means x does not equal 3. X equals 3, x does not equal 3. Those have opposite truth values. They're negations. Okay, on to this next bit. I've got a conditional statement here that we're given. This is a new example here. Okay, so I'm going to talk about some different things called, well, this is my if-then statement, okay? So the symbol for that is P to Q, okay? Oh, and I forgot the word he here. I'll put that, I'll fix that on the guided notes. All right, so the converse is going to be when we flip the conditional statement around. So instead of going from P to Q, we're going to go from Q to P. All right. So the hypothesis part here was Tim studied. He passed was the conclusion. So I'm just going to flip that around. So I'm going to, and some people might say if he passed, then Tim studied, and that's not wrong. It's just poor writing because I don't want to say he before Tim. So I'm going to say if Tim passed, then he studied. Okay, so you just flip it around. And, you know, some people might say if Tim passes, then he studies or something like that. I'm not going to be picky about past tense or present tense or that kind of thing, as long as we get the idea of where to put the hypothesis and conclusion, okay? All right, next up, I've got what's called a negation, okay? And the symbol for this, I'm going to have a little squiggly line followed by the lowercase p, and then another squiggly line in front of the Q, okay? And what this means, those squiggly lines means that these are negations, okay? So I'm going to have the negation of the original hypothesis followed by the negation of the original conclusion, okay? By the way, I don't know who Tim is or if he passed or not. I'm not really worrying about if any of these statements are true or false. I'm just taking the original conditional and rearranging them to get these different things, okay? So I'm going to say if Tim didn't study or did not study, then he didn't pass or something like that. Okay, so there we go. That's called the inverse. Okay, these are really easy to confuse. So you got to spend a little time memorizing which one is which. Okay, and the last one, the contra-positive, the fanciest of all, is kind of a combination of a converse and an inverse. So I'm going to switch the order, but I'm also going to negate. Okay, so I'm going to take the negation of Q, leading to the negation of P. Okay, so if I'm looking at the original one, I'm going to take the Q part first. So I'm going to take the negation of it. I'm going to say if Tim didn't pass, then he didn't study. Okay. So Yeah, so you need to know what a conditional is, and then these three variations on those conditionals. Okay, so I wasn't worrying about the truth value. Again, I don't know who Tim is or if he studied or passed or not. But there is a relationship between the truth values of the conditional, of the original conditional, and the contra-positive. So, and this works no matter what. These two always have the same truth value. Okay, and what I mean by that, they're not, I don't know if that's true or false, but if this is true, then the contrapositive is going to be true. If this is false, the contrapositive is going to be false. You're not going to get a mix. They're either both going to be true or both going to be false. The other two can go either way. So just because this is true doesn't mean that one's false. These are kind of free agents with the converse and inverse. You have to just judge them based on their own merit. Okay, so there's the first page. So next is an example. So I'm just going to do another example like this where I'm writing the converse, inverse, and contrapositive, but then we're also going to look at the truth values, okay? So if you want to pause the video and try it out, you're welcome to do that. I'm going to go straight into it. So this says if you're in New York, then you're in the US, okay? So I'm not going to worry about the truth value yet. I'll do that at the end. I'm going to start actually by doing the, just reminding myself, that's the original conditional. The converse is when you switch it. Okay. The inverse is when you leave it in the original order, but you negate both parts. So negation of P leading to the negation of Q. And the contrapositive is when you switch and negate. Okay. And so, this part would be the P part, the hypothesis, and this is the conclusion. Okay. All right. So let's look at this then. If I'm going to switch the order, I'm going to say if you're in the US, then you're in New York. Okay, there's my converse, my inverse. I'm leaving them in the original order, but I'm going to negate. So I'm going to say if you're not in New York, then you're not in the US. Okay, all right. And then we've got contrapositive where we switch and negate. So I'm going to say if you're not in the US, then you're not in New York. Okay, so there's those four. And then the second part of this, find the truth value of each. Okay, so that just means say if each statement is true or false. So let's start with the original conditional. If you're in New York, then you're in the US. Well, maybe there's a New York somewhere else in the world besides the one in the US, but I don't know of another. So sometimes you just have to judge these based on your best knowledge. So I'm going to go true for that one. Okay. If you're in the US, then you're in New York. Nuh-uh, right? I am in the US and not in New York right now, so this would be false. Okay. If you're not in New York, then you're not in the US. Well, in Walnut Creek, you're not in New York, but you are in the US, so that is false again. Okay. And then the contrapositive, if you're not in the US, then you're not in New York. So if you're outside of the US, then you're definitely not in New York, so this one is true. Okay, and you can see how these two had the same truth value. Okay, now it just so happened these two were false, but they're not necessarily linked to each other, and they're not definitely there's no pattern with the converse and inverse. You just have to think about if they are true or false. But these two always go together. Okay. Next up, I want to talk about a counterexample. So a counterexample is one example that shows a statement is false. Okay. So for example, I talked about a counterexample. I gave a counterexample when I was talking about if you're in the U.S., then you're in New York. Well, Walnut Creek would be a counterexample. I mean, sometimes when you're in the U.S., you are in New York, but not always, right? So the fact that you could be in Walnut Creek, that's a counterexample, and it shows that this statement is false. So you just need one counterexample to show that a statement is false. Okay, so let's find a counterexample here. If an animal is a bird, then it can fly. Well, what about a bat? No, never mind. I want to start with an animal being a bird. A bat can fly, it's not a bird. I got that mixed up. Okay, so I want to think of birds that can't fly. So there's a few of them. A penguin is one example, and it only asks for one, but you could say ostrich is another one. I think chicken and turkeys are debatable because they could fly a little bit, but there are other examples out there, like kiwi is another one, or an emu. Okay. Next up, biconditional statements. So this is, you've got some sort of statement, then the phrase if and only if, and then some sort of other statement. So I call it an if and only if statement. You can have all sorts of things on the two ends. The symbol for this is P to Q, but it also works Q to P. So you've got a double-ended arrow there. So you can actually flip this around and say Q to P. And it works in either direction. It's always reversible. Okay. The conditions for a true biconditional, if you want a biconditional that works, you need a true conditional, so that means if the hypothesis does lead to the conclusion, and that's it, that works, and you need a true converse, so it needs to work in the other direction, because the converse goes from the original hypothesis to the original conclusion to the original hypothesis. Okay, so I'll show you what I mean here. So we're going to write a true biconditional if possible. So I could take any phrase and write it as an if and only if statement, but I want to see if it actually would work, if it would be true. Okay, so I've got two angles are supplementary is the hypothesis part. Their sum is 180 degrees is the conclusion. Okay, so I'm going to think about if this works. So as this is written right now, this if two angles are supplementary, then their sum is 180 degrees. That's true. That's a true statement. I'm just going to write true there. Okay, and then I'm going to think, well, would this work in the other direction? I don't want to rewrite the sentence here, but I'm just going to imagine what it would look like. Okay, so if I had this statement, if two angles sum is 180 degrees, then they are supplementary. Well, that would also be true. Okay, so I've got a true conditional and I've got a true converse. So that means this is going to work. Okay, so now I can rewrite this as an if and only if. So I can say something like this: two angles are supplementary. I'm going to abbreviate a little bit to make this quicker. Two angles are supplementary. That's the hypothesis, and then if and only if their sum is 180 degrees. Okay, and that is my true biconditional. I check that it works both directions. And you could flip this around. You could say if two angles sum is 180 degrees, or sorry, two angles sum is 180 degrees if and only if they are supplementary. That would work as well. So you can write them in either direction. Okay, and on to the last page. All right. Oh, this is writing another biconditional, so you can pause it and try that. So I'm going to think if this works. So if I'm going this direction, the original direction, if you're a quarterback, then you play football. As far as I know, that's true. I don't know of quarterbacks in any other sports or anything like that. Okay. Let's think about it the other way. If you play football, then you're a quarterback. Well, there are other positions. You could be a running back or a wide receiver or anything like that. So that I could come up with counterexamples for the converse. So that's going to be false. So that means I can't write a true biconditional here. So I could say not possible. And if someone asked me why, I could say because the converse is false. Or you could say it's not reversible, or you could say because you could be a wide receiver, play football and be a wide receiver or whatever. You could actually state a counterexample to show why it doesn't work. Okay, there's an answer for that one. Okay, all right, and then the last part in this section has to do with using definitions. So the idea with well, let's just work through this. Okay, it says based on the diagram, find the truth value and justify. Okay, so looking at this, is AEB, oh, I forgot to put this point in the middle here, was point E. I'll fix that too. Is AEB a right angle? And we can use definitions here, okay? So it shows in the diagram that, well, it actually shows that this one is a right angle, but then we've got a linear pair there, right? So that means I've got 180 total degrees. This must be 90 degrees too. That symbol really just means those two lines are perpendicular, which means I've got right angles all four of those spots, okay? So I'm going to say that that's true. So it says find the truth value, okay, phase one complete. And then it says to justify. So I'm going to justify that based on the definition of a right angle. A right angle is two 90-degree angles, and it has the symbol for perpendicular there. So I'm going to say definition of a right angle. Okay, and I'm going to use some abbreviating there. I put that in parentheses just to show that that's my justification. Okay. All right, next one, A, E, and B are collinear. A, E, and B are collinear. Well, they're not. They're not all on one straight line, right? You'd have to turn a corner there. So my it's false. And then my justification, I'm going to say, well, the definition of collinear tells me that those are not collinear, right? Because that's not what collinear means. Collinear means they're in a straight line. So again, I'm going to say definition of, and I'm just using DEF for definition of collinear. Okay, and the last one, it's a little hard to see and probably here, but there's little arrows. These are supposed to be symbols for rays. Are AC and CA opposite rays? AC is this ray, and CA is this ray. Well, they are going in opposite directions, but no, they're not opposite rays because they don't have the same endpoint. If they went like this, they would be opposite rays, but they overlap, right? So that doesn't count. So this is going to be false. And the reason why it's false, because it doesn't work with the definition of opposite rays. Okay. And that is the end of the section. See you next time.